Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. I'm going to give you yet another example of what we've been talking about in the last some number of videos, namely giving an arbitrary sentence, reducing it to first degree, and then converting it into ordered modal conjunctive normal form. So if you're happy with both of these processes, skip this video. It will be deadly dull and boring. If you're not comfortable with both of these processes, can't guarantee that the video still won't be deadly dull and boring, but let's do it anyway. So here we are, we've got our whiteboard, and the formula that we are going to look at is a random collection of modal operators and proposition letters. If it is necessary that possibly P implies P, then it is necessary that P implies necessary P. So no, we're not saying anything about whether this is a theorem of S5 or whether this is an interesting modal formula or anything. It's just an arbitrary formula, and we are going to do two things to it. We are going to first reduce it to first degree, and then we are going to convert it to ordered modal conjunctive normal form. So first thing to note is that the first step isn't redundant. We do need to reduce it to first degree because it's got embedded modalities and it's got iterated modalities. So we know that it's not first degree, and we can bring it down into this case. There's so first thing that we're going to do is to get rid of all of the arrows. So we'll convert all of the implications into disjunctions. So that will be adding a negation there, changing that implication to a disjunction, adding a negation here, changing that one to a disjunction, and then changing that one to a disjunction, adding a negation. So the result of the first step is that we have not box, not diamond, diamond, P, or box, not P, or box P. Now what we want to do is we want to get all of those negations as close to the atomic letters as we possibly can, i.e. all the way over. And we only need to do that on this left-hand disjunct because here we've already got our negation is attached to an atom. So this will involve both De Morgan's laws, double negation, and modal interchange. The first thing is we will swap this negation and this modal operator. So that becomes, instead of not box, becomes diamond not. And then same thing, we can do that here. So the two diamonds each become a box, and we drive the negation through. So we've got box, box, not P or P. And then we still have this last negation here that we want to push through. And now I'm just realizing that if I had done De Morgan's first, I could have simplified things, but I didn't. So if I do De Morgan's now, I get not box, box, not P, and not P. And now I've got to do modal interchange and some double negation again. So this not box, box, not becomes diamond, diamond, not P, P. And then we can just get rid of those two. So as I said, the other disjunct doesn't change. So we are now at possibly P and not P, or necessarily not P or necessarily P. Now we want to distribute the modalities, and we've only got the one that we need to worry about. It's this one here on the outside. Distributing a modality generally can't be done over a conjunction, you remember, because while possibly P and Q does imply that both of the conjuncts are possible, you can't go the other way around, and we need to have equivalences, not just implications. However, you recall from the very useful S4 equivalences that I had, you can distribute a diamond over a conjunction when at least one of the conjuncts already has a modal operator. So this gets us possibly P and possibly not P, or necessarily not P or necessarily P. And now we've got the same thing here. Ordinarily, you cannot distribute a disjunction, a box over a disjunction, but you can in S5 when you've got one disjunct that is modalized. So distributing this guy, we get this remains unchanged. And then over here, we have either box not P or box P. There we go. And then the very last thing that we need to do is get rid of our iterated modalities. We've only got this. So now we've got possibly P and possibly not P, or necessarily not P, or necessarily P, which is actually a pretty cool formula to end up with, considering that what we started off was this random weird thing that didn't really seem to say anything interesting. But this is first degree. So we have done step 1. Now we want to convert it to ordered modal conjunctive normal form. So remember, this is a conjunction of disjunctions where each disjunct is either purely propositional of the form box phi or diamond phi, where phi is purely propositional. So you can already see why reduction to first degree is going to be good, because now all of the little components that we have are the right kind. So they are either a box followed by something that doesn't have any modal operators, or it is a diamond followed by something that doesn't have modal operators. The problem that we have right now is that our main connective is a disjunction, and therefore this isn't a conjunction of disjunction. It's a disjunction of one conjunction and one disjunction. This is all messy. So we do need to do this conversion process. And the first thing that we will do is distribute the disjunction over the conjunction to get it into the right form, to have the right main connective. So I'm just going to bring the formula over here so we've got it nicely written up. We've got possibly P and possibly not P, or necessarily not P, or necessarily P. So what we are doing is we are going to be taking this bit and distributing it over the two conjunctions, the two conjuncts that we have in the other disjunction. So first step means that we've either got possibly P, or we have necessarily not P, or necessarily P. And we also have the other possibility, namely possibly P, or necessarily not P, or necessarily P. I'm running out of room. How terrible. Okay, have I matched all my parentheses? Yes, I have. So the next thing that we can do is we can remove some of these superfluous parentheses, because now we have a conjunction of just disjuncts. So possibly P, or necessarily not P, or necessarily P on the one hand, and possibly, oops, that should have been the not P because that one was coming from here, possibly not P, or necessarily not P, or necessarily P. So these are the two possibilities that we have, one on either side. So this is now in modal conjunctive normal form. It is a conjunction of disjunctions of which each disjunct is of one of these forms, but we want it to be in ordered modal conjunctive normal form, which means first we take all of the, we take all of the necessity formulas, and then we take all of the possibility formulas. And if we had more than one possibility formula, we would have to bundle them together so that we only ended up with one, but we only have one, so we don't need to do that step. And then the other conjunct is going to be, again, necessarily not P, or necessarily P, or possibly not P. So we put the necessity formulas first, and then the possibility formula at the end. As it turns out, this doesn't have anything that is purely propositional, but that's okay. It's just that whatever the disjunctions are, it has to be one of these three kinds. It isn't the case that we have to have one of every kind in order for it to be modal conjunctive normal form. So there you have it. We took this arbitrary random formula that we started with, we reduced it to first degree, we converted it into modal conjunctive normal form, And then we did the proper ordering, and there you go. Hopefully this was useful, even if not particularly interesting. The interesting stuff is what's going to come next, because once we have something that is in ordered modal conjunctive normal form, I'm going to teach you a process via which you can determine from that form whether or not the thing is a theorem of S5. And if it is a theorem of S5, I'll tell you how to prove it. This is going to be fun. So join me next time, and until then, take care. Cheers.